Hey everyone, Norman here with the McWane Science Center, back again with another SciSpark. What do baking and a common heartburn medication have in common? How can we use this knowledge to launch a rocket? To find out, we're going to make a bit of a mess as we explore Fizzy science. Have you or someone you know ever found yourself with heartburn after a really heavy meal? One common treatment is Alka-Seltzer. When you plop an Alka-Seltzer in water, you will immediately get some fizzing, which is one of the useful things about this medicine. That fizzing action can soothe your stomach by acting as an antacid. Plus, the tablets typically contain acetylsalicylic acid, aka aspirin, for the pain. But what causes this reaction? It's actually very similar to the old volcano experiment using vinegar and baking soda. When you combine something known in chemistry as a base, like baking soda, with an acid, like vinegar, also known as acetic acid, and a little food coloring, you get the not so creatively named acid-base reaction, which generates water, some kind of salt, and often a gas like carbon dioxide. The carbon dioxide is what causes the reaction to effervesce, or fizz, as all the dissolved gas tries to escape. Now, back to Alka-Seltzer. Alka-Seltzer has 3 main ingredients. The first, as mentioned, is aspirin. The other 2 are an acid and a base. The base, again, is baking soda, but the acid is citric acid, the very same acid that flavors citrus fruits. Baking soda, or sodium bicarbonate, is a sodium base used in, well, baking. When it combines with an acidic ingredient like vinegar or lemon juice or buttermilk, it often produces carbon dioxide, which leaves foods extra light and fluffy. Did you realize that a lot of cooking is basically just science with the kitchen as a laboratory? So why don't the citric acid and baking soda react until you drop the tablet in water? Well, dry acids and bases, like this citric acid and baking soda, can't mix together that well and kickstart their reaction. But when you dissolve them in water, then the molecules are free to interact and you get this fizz. The products of this reaction are, of course, carbon dioxide, but you also get water and a dissolved salt known as sodium citrate, which can actually make the table a little sticky. That being said, it's time to see what this has to do with rockets. Inside of this container, I'm going to put some powdered citric acid and a little baking soda. Now remember, there's no reaction when these 2 powders mix. I still need to add water. Now, when I add water, I'm going to quickly cap it off. This will allow the carbon dioxide and sodium citrate inside to form, but will prevent the gas from escaping, increasing the air pressure inside until all right, now that I've made a mess, I think that's as good a place as any to end today's SciSpark. Thanks for watching, and if you liked what you saw, be sure to leave a like and subscribe for more content. Until next time.